discussed about searching algorithm, insertion, deletion algorithm, but we didn't discuss about any sorting algorithm. Okay. So our today's topic is bubble sort. So have you heard the term bubble sort?
Yes, sir.
Yes. I think you all have heard about it in your C programming course, that is bubble sort, because this is a very famous or frequently used algorithm for sorting something. So what is sorting? Sorting means rearranging things. Suppose some characters are given, or we are arranging some names in a database, or we are arranging some numbers in a table, and if we want to arrange them in ascending order or in descending order, or if the data is in alphabetical form, that is some letters are given, we can arrange them in alphabetical order, right? So sorting means arranging something, and we need this sorting algorithm where in binary search also, right? For searching some data elements, at first we have to sort, we have to arrange them in ascending or descending order. So how we can sort them? By using the sorting algorithm, and there are several sorting algorithms we can use, that is insertion sort, selection sort, heap sort. So many sorting algorithms are there, but we'll start with this one, with bubble sort. Okay. So at first we need to know what is the logic of bubble sort algorithm. Its goal is to rearranging the data. Suppose some data elements are given, that is 18, 20, 22, 24, then 22, and then 26. Suppose this is an array which has how many elements?
5.
5 elements. And
Five
if we
elements.
start the index from 0, that means the first position will be 0, after that 1, 2, 3, and 4. So how the data are actually organized, how they are stored in the array. Is the array sorted? Just look at the array, is it sorted?
No, ma'am.
No, ma'am.
No, ma'am.
Right? So if we want to sort the array in ascending order and descending order, we need to apply this sorting algorithm. Okay, so in today's class, we'll get to learn how to sort or how to organize the data in ascending order and descending order using bubble sort algorithm. Okay, so here at first we have to find out, or we have to identify how many data elements are stored here. 18, 20, 24, 22, 26. That means in this array, the number of data is 5. Right? And the first element is 18, and then 20, and then 24, 22, 26. So if we want to sort these 5 numbers or sort the array in ascending order, so the output should be like this. At first, we need to store the lowest digit, lowest number, that is 18, then 20, then 22, after that 24, and then 26. Right? So how we can sort this now? Sort this array with how many elements are here? 5 elements. So can we just print this list or print the array? After one comparison, how we can sort these 5 numbers? So in bubble sort algorithm, every time it will take 2 neighboring or 2 adjacent numbers, and then it will compare these 2 numbers. Suppose the first 2 numbers are 18 and 20. So it will take these 2 numbers, and then it will find out which one is the smaller number, because we are trying to sort the array in ascending order. Okay, so the bubble sort algorithm will take 2 adjacent numbers, and then it will compare them. After that, one the greater number with the next data elements, and that is the concept of bubble sort algorithm. Is it clear how it will work? when an unsorted array is given, and if we want to apply the bubble sort algorithm, then every time it will take how many numbers? Only two numbers, and then it will compare these two numbers, and the smaller number will be added first. After that, it will compare the higher one with the next data element. Okay, so how many steps or how many comparisons actually we need for sorting 5 data elements? In this array, the number of element is 5, right? And
So
after
ma'am, four
each
time
pass,
comparison.
very good. We need actually not 4, we need multiple comparisons here. I'm writing the data again, that is 18, after that 20, and the next one was 24, right? Then 22 and 26. And these are their position 0, 1, 2, 3, 4. And what is the logic of bubble sort algorithm? Every time it will compare two number. Okay. So suppose we want to, suppose this is our pass 1 or step 1, and how we can organize the data. At first we'll compare 18 and 20. After comparing these two results, so what will be the output? Which element will be stored first? Obviously 18. That means when the compiler or when bubble sort will compare the first two number, it doesn't need to swap. I mean, is there any swapping will be done here? No, because 18 is a smaller number, 18 is smaller than 20, so it will not perform any swap here, isn't it?
Yes, ma'am.
And then it will compare the next two elements 20 and 24. So here 20 is smaller than 24, isn't it?
Yes, ma'am.
Yes,
That
ma'am.
means no swapping will be done here also, right? So we can simply write 24. Now after that, it will compare the second two data, 24 and 22. So how to compare these two number? Obviously, its position will be changed. Now the position of 24 will be changed. Here we need to write 22, and after that it will store 24. And then again it will compare 24 with 26. So how many comparisons we are doing here actually? N minus 1, right?
Yes, ma'am.
But what
Yes,
I
ma'am.
told, in one comparison, in one step, it can compare only two data, only two number. That means all these comparisons cannot be made in one step. So how we can write all the steps within pass 1? How we can write them? How many passes we need? N minus 1, right? And inside each of these pass, there will be total N minus 1 comparisons. So how we can write all these steps here? Suppose this is our first pass, right? And the first two numbers are 18 and 20. So at first, bubble sort algorithm will compare these two numbers, and now it found out that 18 is smaller than 20, so it will not perform any swapping here. So the arrangement of these 5 numbers will be 18, 20, 24, 22, and 26. Is that clear? This is our first comparison within pass 1. At first, bubble sort algorithm will compare 18 with 20, right? Now after that, in the second comparison now, it will compare 20 with 24. That means we can just write 18 here, right? So between these two number 20 and 24, which one is smaller? 20. That means it will not swap this two data element. We can write 20 and 24. And the next element is 20 and then 26, right? And now the third comparison will be, it will compare 24 with 22. And how we are arranging the data in ascending order, that means all the elements which is smaller, then the next one will be stored first. Here the first element is 18, which is smaller than 20. And then now we are going to compare 24 with 22. and we can see that the position of 24 is 2 here, isn't it? And 24 is greater than 22, so we need to change the place of this two number, isn't it? So now 22 will take the place of 24 and it will be stored in memory location 2. After that you can store 24 here, and this is the last data 26. Now the comparisons will be made between this two number 24 and 26. So at first we can write this three number 18, 20, 22. Okay, and between these two numbers, which one is smaller? 24, right? So we can just simply put this number in its original place, that is 4, and then the number will be taken 26. Is that clear?
Yes, ma'am.
Okay, so now look at the data 18, 20, 22, 24, 26. Are they in a sorted manner? I mean, how we have taken the numbers. At first, the arrangement was 18, 20, 24, 22, 26, but after only one pass, we got a sorted list. That is 18, 20, 22, 24, and 26, isn't it?
Yes, ma'am.
Yes, ma'am.
So how we can say that for sorting n number of elements, the total number of pass should be n minus 1, or total number of comparisons should be n minus 1, because here after one pass we got the sorted list. Isn't it? How many passes we needed here? Only one pass. And in bubble sort algorithm, actually we need n minus 1 number of pass, and inside each of these pass we need n minus 1 number of comparison. But here we can see that after only one pass and after only 4 comparisons we got the sorted list. Why that happened? Because of this data. So now we can take some random numbers such as 18 and then 34, okay, then again 24, then suppose 38, and then 14. Now again we took an array where the number of element is 5 and they are not sorted, right? So here n equals to 5, that means we need actually how many pass? 4 passes, n minus 1 number of pass. And after one pass, only one element will be placed in its correct order. So how we can start the comparison? Suppose this is pass 1, pass number 1 or step number 1. So how bubble sort will compare the number? Every time it will take two adjacent numbers, 18 and 34. So here, do we need to make any swapping here? No, because 18 is smaller than 34. So after the first comparison, this is comparison number 1. After first comparison, the first element will be 18 and then 34. The next one is 24 and then 38 and then 40. Okay, now we need to perform another comparison, that is comparison number 2. Do we need to compare 18? No. In the second comparison, these two elements will be compared, right? So between 34 and 24, which one is smaller? Obviously 24. Isn't it? So now we can make a swapping here. 24 will take the place of 34. 24 is smaller than 34, that's why we can take it before 34, right? It's 38, 14. And in the next comparison now, which two data element will be compared? Obviously 34 and 38. And what will be the output, or which one will be placed in position 2 and which one will be placed in 3? Same, right? Because 34 is smaller than 38, so we don't need to change the position of these two numbers. We can write 34, 38, and the last one is 14. Okay, now we can perform another comparison number 4. The first data is 18 and then 24. The third one is 34, and now 14 is smaller than 38, so obviously we need to change the position of these two numbers, right? So 14 and then last one is 13. Now look at the output. After performing how many comparisons? 4 comparisons within the first pass, we got this array with 5 numbers, and here the numbers are 18, 24, 34, 14, and 38 are So here this list is not sorted, right?
Yes, ma'am.
After pass 1, we can see that only one number is in, its correct position. Look at the numbers here. 38 is the highest number, so it should be placed in the right side. After comparing how many numbers, there are total 5 numbers. We could place only one number in its correct position or place, 38. So now if we want to place another number in its correct position, we need to perform the second pass, right?
Yes,
Yes, ma'am.
ma'am.
So that means in pass number 2, so now how we can compare the data elements. In the first comparison, 18 and 24, this number will be compared. And after the first comparison, we can see that 18 is smaller than 24. So swapping is not needed here. So we can take 18 and 24. After that, you can write all the other numbers, that is 34, 14, and 38. And in the second comparison, again here 24 and 34, do we need to swap, do we need to change the position of this number? No, because 24 is smaller than 34. So after the second comparison, the ordering or arrangement of the data will be 18, 24, 34, 14, and then 38. So I'm just writing third comparison here, comparison number 3. So now which two data elements will be compared? 34 and 14, isn't it?
Yes, ma'am.
Okay, so here after this third comparison, we can write 18, 24, and now 19 will take the place of 34. So 19 and then 34 and then 38.
Ma'am, that's 14, not 19.
Sorry. This is 14. Okay. So now these two numbers will be compared. That means we need another comparison. And after this comparison, the arrangement will be 18, 24, then 14, 34, and 38. So now look at this. Inside the second pass, it's pass number 2. How many comparisons we needed? N minus 1 number of comparison. And after the comparison, we can say that now two elements, 34 and 34, are in their right position. Isn't it?
Yes, ma'am.
Okay, so now here the list is not sorted because 14 is smaller than 24, also it's smaller than 14. So the list should be like this: 14, then 18, 24, 34, 38. That means we need to perform another series of comparisons. Okay, so can I remove
Sure, ma'am.
this portion?
Yep.
Okay, so now the pass number or step number will be 3. Okay, so inside that pass, how many comparisons we needed? How many comparisons?
Still 4.
4 comparisons. So now it's pass number 3. And the data element is 18, 24, 14, 34, and 18. So I'm just writing the data here. Eighteen, 24, then 14, 34, and 38. Okay, so this is a first comparison number 1. The first two data will be compared, 18 and 24. Still 18 is smaller than 24, so the data will not change their position, right? So 18, 24, and then 14. The next data will be 34 and then 38. In second comparison, now we are going to compare which elements, these two numbers, 24 and 14, right? So here 24 is greater than 14, so we need to change their position. Now 14 will be stored before 24, and then 24 will take the position.
What's wrong is happening with my...
data will be 18, 14, 24, then 24 and 38. Now after pass number 3, we can say that these three elements are in their right position. 24, it's 34 and 38. Is that clear?
Yes, madam.
Yes, ma'am.
Yes, ma'am.
So is the
Madam,
list sorted? No, it's not sorted because 18 is the first element which is greater than 14. That means we need another pass here. So in pass number 4, we have to make 4 comparisons. At first, we'll compare in minus 1 position. One item unsorted. I mean, we didn't compare or we didn't actually perform any pass for the first red element 14. But we need another pass number 5? No, because already 14 is its in right position. That means for n number of element in bubble sort algorithm, we need n minus 1 pass, and inside each of these pass, we need how many comparison? N minus 1 number of comparison. And that's why the time complexity of bubble sort algorithm is n square. Because how many loop we need here? 2 loop. One is outer loop for these passes and another is inner loop for the comparison. So the time complexity of bubble sort algorithm is n square. Is that clear?
yes, ma'am.
What about the others? Is that clear?
Yes, ma'am.
Okay, so if it's clear to you, then I'm giving you another data set with 6 numbers or 6 data. So you have to arrange them in ascending order. Okay. So the data elements are 32, 14, 2, 25, 41, 17. Okay, so this is an unsorted array, and what is the value of n? N equals to 6, right?
5, ma'am. Oh, number
So
5.
their position is 0, 1, 2, 3, 4 and 5. So here n equals to 6. Okay, so how many passes we need here? 5 passes. The number of passes will be n minus 1, that is 5. And how many comparisons we need here? Same, n minus 1. Okay, so bubble sort algorithm cannot compare more than 2 numbers at a time. So at first it will compare 32 and 34. After that it will compare 14 with 2, and then 2 with 25, then 25 with 41, after that 41 with 17. In pass number 1, how many elements will be sorted? How many data elements among those 6 will be sorted or will be placed in the correct position?
1.
Only 1. And which one? The higher. The greater number is 41. 41 is the highest data element here. So after pass number 1, only 14 will be placed in the correct position. So if we want to place another data element in the right position, we need another pass. After pass number 2, then which one will be placed before 41? 32. And after that 25, then 17, and 14, and then 2. Isn't it? This is the sorted list, and after 6 passes we will get the list, or we will get the sorted array. Is that clear?
Yes, ma'am.
Yes, ma'am.
Or you can just try to actually solve it. Okay. Um, there are 6 elements, so just try to find out that how many comparisons you are actually using inside each of these passes. Okay. Can you see the screen? Hello.
Yes, ma'am.
Yes, ma'am.
Okay, so which data elements we took? We Okay, so we can take some random numbers such as 32. Okay, suppose you are taking an unsorted array with 6 elements or 7 elements, and the elements are 32, 12, 2, 7, 27, then 21, 30, and then 15. Okay, so now we can look at this. This is the unsorted array with how many elements? 32, 7 elements, and the elements are 32, 12, 2, 27, 21, 30, and 50. The number of element is 5, and we need how many passes here? 6 passes, and inside each pass there will be total 6 comparisons. Right? So now we'll see how it will sort, how the bubble sort algorithm will sort the numbers. So at first, which data element will be sorted? 12. Let me just decrease the speed. Okay. We can start from the beginning. So the first 2 data elements are 32 and 12, right? That means 32 is greater than 12, so we need some swappings here. 12 will take the place of 32, isn't it?
Yes, ma'am.
So now, after the first comparison, the ordering will be 12, after that 32. Now the bubble sort algorithm will compare next two adjacent numbers, that is 32 with 2. So which one is smaller here? 2. So now 2 will be stored before 32. So now look at the, so 2 has taken the place of 32. After that, the algorithm will compare 32 with 27. Again, 32 is greater than 27, right? So again, some sweepings will be done here. So which one will be stored first, 27 or 32?
27.
Obviously 27, right? Again, now the algorithm will compare 32 with 21. So now at first 21 will be placed and then 32, right? And now which two numbers will be compared? 32 with 30. And 30 is smaller than 32. So at first we have to take 30 and then 32, right? And now the last two numbers are 32 and 15. So again, it will serve the position. So 15 will be stored before 32. And this is the array we got after the first pass. So just look at the numbers. Now the data elements are 12, how they are organized here. The first one is 12, 2, 27, 21, 30, 15, 32. And here the list is not sorted, but one data is in the right position. 32 is greater than all the other elements of this array, and it has taken its correct right place. The location of 32 is 6. So now if we want to put another element in its right position, we need another pass, right? So from where it will start comparing the elements? Obviously from the first location, right? From here it will start comparing the data elements. So it will compare 12 with 2, isn't it?
Yes, ma'am.
Yes, ma'am. Yes,
Now
ma'am.
12 will take the place of 2. I don't know, it stopped working. Okay, so the first pass is done now. Now it will start the second one. Okay, so it will compare 12 with 2, and 2 is smaller than 12. That's why it first stored 2 and then 12. So now the next comparison is between 12 and 27. So what do you think? It will swap the elements or not?
No, it's on the right
No,
position.
ma'am.
No, because 12 is smaller than 27. So after the second comparison, this will be the ordering of the data, that is 12 and then 27. So now it will compare 27 with 21. Again, their position will be changed. The ordering will be 21 and then 27. So now the comparison is between 27 and 30. 27 is smaller than 30, so the data element will not be changed. And then the next comparison is between 30 and 15. Okay, so now 15 will take the place of 30. Okay, so that is the next comparison, and after that this two data element will be compared, 30 and 32. 30 is smaller than 32, so now 30 is placed in which position? In location 5. So after the second pass, two elements are in the right position, that is 30 and 32. So for organizing or for placing each data element in the correct position, we need one pass. Okay, so if we want to organize 7 elements, if we want to sort an array with 7 data elements, we need maximum how many passes? 6 passes. But sometimes maybe we need less number of passes, and it depends on which data element you have taken. Okay, so is it clear, the bubble sort algorithm, or how it actually works?
Yes, ma'am.
Yes, ma'am.
Okay, so if it's clear to you, now can you write the algorithm? How many loops we need here? We know that time complexity is order of n square, because here we need two loops. One is inner loop and another is outer loop. And this outer loop is actually needed for counting the number of passes, and the inner number is needed for counting the number of comparison. Right, and how the bubble sort algorithm is actually comparing the numbers. Suppose this is the array with 4 elements, 12, 20, 32, 12, 20, and 14. And if the location of this data element is 0, 1, 2, 3, and if the name of array is A. So now at first we'll compare A0 with A1, isn't it? Look at the array. The array has 4 elements and the index is 0, 1, 2, 3. So A0 means 32. And what about A1?
12.
A1 means
12.
12. So the bubble sort algorithm at first will compare which two elements? A0 with A1, isn't it? And here A0 is greater than A1, right?
Yes, ma'am.
When A0 is greater than A1, that means it needs to change the position of 12 and 32. After swapping, 12 will be placed where? In location 0, and A will be placed in location 1. So at the time of this swapping, where it will store the data element 32. Look at this array. When it is comparing the first two data elements, that means it has taken 32 and 12, right? After that, when this condition is true, A0 is greater than A1, that means now 12 will be stored here and 32 will be stored in location 1. Isn't it? So when it has taken 12 and 32 from the array, and before placing 32 in memory location 1, it needs to place that data in another temporary variable. Look at this. It has taken how many data from 0 and 1 memory location, 12 and 32, isn't it? After comparing these two data elements, now 32 is greater than 12. So at first it will place 32 in a temporary variable. After that it will place 12 in the memory location 0, and then from that temporary variable it will collect the data 32. Then it can store it in the next memory location, that is 1. That means in this program we need how many variables? Do we need to explain it again? Hello, can you all hear me?
Yes, ma'am.
This is bubble sort algorithm, and why we're using it? For organizing the data in an order, right? So if we want to organize the data in ascending order, that means we have to make some comparisons, we have to change the location of some data elements, right? And if we're using bubble sort algorithm, it can only compare two data elements at a time, right? So when it's comparing two numbers, it cannot place both these numbers in the memory location at a time. That's why it needs a temporary variable for temporarily storing the largest data element. Between these two numbers, which one is largest? 32, right? So now after taking these two elements from the array, it can place 12 in the first memory location, but at that time it needs to place the largest data element in a temporary variable. Suppose this is the temporary variable, and inside this variable it can store 32. After placing 12 in the first memory location, now it will collect the data 32 from this temp variable, and then it can store it in memory location 1. Right, so now tell me, if we want to write the program, then how many variables we need to declare?
Temp, then data large.
Okay, we need temp.
3.
Very good. We need 3 variables. We need 2 loop variable, one for the outer loop and another for the inner loop. So we can declare 3 variable I, j, and temp. Is that clear? How many
Yes,
variables we need here? 3 variable, one for the inner loop, and in inner loop, look at this here, the number of element is 4. That means for each of these number, we need to conduct a pass. So here the value of I, it denotes, I mean here, if we are taking the value 0, that means we are executing a pass for which data element? For 30, for which one? For 32. Isn't it?
Yes, ma'am.
What is the purpose of these passes? After the first pass, the largest data element will be placed in the correct position, isn't it? So after this pass, when I equals to 0, that means one data element will be placed in the correct position. So here, this I will be used as outer loop variable. And what about this j? J will be used as inner loop variable. And here we need the inner loop for counting the number of comparisons. Let me write these things here. Okay, so here the number of element is n equals to 4. Okay, so after first pass, that means when I equals to 0, only one element will be placed in the correct location. So here I equals to 0. And how many comparisons we need here? Obviously 3 comparison, and after the first comparison, 12 will take the place of 32. So it will be 12, 32, and then 20. After that, 14. And in the next comparison, now which element we can compare? 32 with 20. And 20 is smaller than 32. So at first we need to take 20, and then 32, and the last one is 14. Okay, now the comparison number 3, and here we can compare 32 with 14, and 14 is greater than 32, so it will be placed before 32, isn't it? So after pass number 1, only one element is stored in the right position, isn't it?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So that means by using only three comparison, by using n minus one number of comparisons, that algorithm compared all the numbers, all these four numbers. So this, for counting the number of comparison, we need a variable that is j. Okay, that means j will be used as inner loop variable. Is it clear now?
Yes, ma'am.
Yes, ma'am.
Okay, so here after declaring three variable I, j, temp, now we need to write this loop. So how we can set the condition now? The value of I depends on the number of pass, and here n equals to 4, so we need total 3 passes. So can we say that for I equals to 0, I less than n minus 1 I plus plus. Is it correct? Is it correct or not? I equals to 0, I less
Yes,
than
ma'am.
n
And
minus 1 I plus plus. And here this I, we are using it for the number of passes, right? So when n equals to 4, we need total 3 passes. That's why we set the condition I less than n minus 1. But if we take the initial value of I as 1, if I equals to 1, at that time the condition will be I less than n. I less than equals to n minus.
I plus plus.
Is it clear?
Yes, ma'am.
Okay, so now we need to take the another loop, that is the inner loop, and here the variable is j. So what will be the initial value of j? Suppose it's 0. Now how we can set the condition? For each of these pass, we need how many comparison?
Three comp.
ma'am, three
Comparisons.
comparison.
So here we can
Limit
write
I.
for j equals to 0, j less than n minus 1, j plus plus. Right? Is that clear? Okay, so now the second loop, the inner loop, is for the comparison, right? And how the bubble sort algorithm is comparing the numbers. Look at the first comparison when the data, that is A0, was 32 and A0 is 12. That means A0 is greater than A1. A0 is greater than A1, right? So at that time, the highest, which one is greater than, 32 is greater than 12. The
Yes.
lower data element is 12. That means we can place 12 in the first memory location, but at that time, the higher one, 32, should be placed in the variable temp. So can we set another, can we use a conditional statement here, that is if AI, if AJ greater than AJ plus 1, then what will be the statement? If AJ greater than AJ plus 1, then how we can set the condition? If
AJ
the
equals
first
to
data
temp.
element is greater than the second one, at that time the higher data element should be placed in the variable temp.
Temp.
So we can write temp equals to AJ. Suppose it's 32 and AJ plus 1. If j equals to 0, when j equals to 0 and 0 is less than n minus 1, okay, so now we can execute this statement. AJ, that is A0 equals to 32, and AJ plus 1, A0 plus 1, that is A1 equals to 12. So now we can write temp equals to AJ. That means 32 will be stored in the variable temp. Right? After placing the higher data element in the variable temp, now the bubble sort will change the position of these two data element. Now 12 will be placed in memory location 0. That means A0 equals to 12. Right?
Yes, ma'am.
Yes, ma'am.
So how we can write the condition over here? Can we write now AJ plus 1 is going to take the position of AJ. Can you write it? AJ equals to AJ plus 1. And here aj plus 1, that is a1 equals to 12. And now we can assign that data where? In a0 location. Now this aj plus 1th element will become the aj element, right?
Yes, ma'am.
Yes, ma'am.
I'm starting from here. Look at this. The condition is if aj greater than aj plus 1. That means when the bubble sort algorithm is comparing two numbers, and if the first number is greater than the second one, then the higher data element should be placed in a temporary variable, and then it will now change the position of the data element 12, right? So this is a j plus 1th element. So now this data element 12 now will be placed where? In a jth position. That's why we have written aj equals to aj plus 1. Is that clear?
Yes, ma'am.
Yes, ma'am.
After that, now here in this step we store the higher element, that is 32, in a temporary variable. Now it will take that data from temporary variable and it will place the data where? In a j plus 1th location. So here we can write a j plus 1 equals to 10. And this is the algorithm of this process bubble sort. Is that clear?
Yes, ma'am.
What about the others? Hello, is it clear to all of you, bubble
Yes,
sort
ma'am.
algorithm?
Yes, ma'am. Clear, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, but again I'm explaining the whole process. This is a sorting algorithm, so the main purpose is to organize the data in its correct position. And if we want to sort the data in ascending order, that means the lower data elements should be stored first, and then we can store the higher data element. So for this array 32, 12, 20, 14, they are not sorted because the first element is 32, again 12, then 20, 14. So when the array has 4 elements, that means we need how many passes for organizing the data in the correct position? We need n minus 1 passes, right? And inside this pass, we need some comparisons, and the number of comparisons also depend on n. Inside these passes, we need how many comparison? N minus 1 number of comparison. And bubble sort algorithm can compare maximum how many data elements? 2 data elements at a time. Okay, so for the number of comparison or for the number of passes, we can use two different loops. One is inner loop and another is outer loop. Okay, so the condition is for I equals to 0, I less than n minus 1, I plus plus. This is our outer loop. And the inner loop is for j equals to 0, j less than n minus 1, j plus plus. What does that mean? When I equals to 0, that means that is our pass number 1. Okay, and inside that for loop we have another loop that is for j equals to 0, j less than n minus 1, j plus plus. And here j variable is used for counting the number of comparisons. So how many comparisons we can have inside one pass? N minus 1 number of comparison. So when I equals to 0, that is our first pass. And when j equals to 0, and how many comparisons we can have from j equals to 0 to j equals to n minus 1. So this is comparison number 1, that means when j equals to 0. Now the bubble sort algorithm will compare two elements from a jth location and a j plus 1 location. And in a0 location 30 is stored, and what is the value of a1? 12, right? So in this statement, in this state, here the condition is if a j greater than a j plus 1, and what is the value of j now? J equals to 0. So a0 is greater than a1 because 32 is greater than 12. Then place the higher data element in a temporary variable. So temp equals to a j. right? After that, now the lower element will be placed where in the first location, in the ajth location. That's we can write aj plus 1 equals to aj. Okay, so after taking 12 from a1 location, now we can take 32 from the temp variable, then we can place it here. Is that clear?
Yes, ma'am.
Okay, so now tell me, can we change this condition j less than n minus 1? Because here some cases we can see here, suppose in comparison number 2. Okay, here the data element is 12, 20, 32 and 14. Or I can take another one. Suppose after a comparison we got 12, then 24, 26 and 28. Okay, and suppose this is pass number 1 and we got this array after comparison number 1. So look at this here. Do we need to compare these data elements? Do we need to perform any other comparison?
No, ma'am.
No, ma'am.
No, but when we set the condition j less than n minus 1, at that time the compiler will actually compare all the other data elements, although we don't need it. Sometimes it can happen that the comparisons are not needed, but the condition we set is j less than n minus 1. That's why it will compare the data elements and it will take more time. The time complexity will be increased, right? So if we want to ignore this thing, suppose here the comparisons are not needed, so we can start the next pass. So how we can change this condition j less than n minus 1? Like if we write the condition j less than n minus I minus 1, at that time we can overcome this problem. Is that clear? If we change the condition that is j less than n minus I minus 1, at that time the number of comparisons will be less than the previous condition, that is j less than n minus 1. So can we write the program in code blocks to just check whether it works properly or not? Okay, so how many parameters we need? At first we need to declare the array, right? So suppose A is an array with 5 elements. So if you want, we can take just n. Here n is the number of element. Okay, so then we can use a scanf function. So scanf, what do you need to write here? We are taking the value of n, isn't it?
Yes, ma'am.
So percentage %d and then ampersand n. Okay. After that, what will be the next step? We didn't declare the loop variables, so we can declare them integer I, j, then temp, right? Okay, so now we declare all the variables that we need in this program, as well as the array and n, that is the total number of element. So what will be the next step?
Writing the for
Loop.
Very good, the loops. So for I equals to 0, I less than n minus 1, I plus plus, and what about the inner loop? For I equals to 0, I less than n minus 1, or you can take n minus I minus 1. It's actually j, not I.
Yes, ma'am.
Madam, you haven't taken the array.
Yeah, I was going to actually discuss it. We didn't took any.
Array.
This is the array. A is the array, isn't it?
But you didn't fill the array.
Okay, let me correct this thing later. Okay, so here the condition is j equals to 0, j less than n minus 1, and then j plus plus. Okay, and inside this loop, we have to set the condition. We have to use a conditional statement if, right? And if ai greater than it's j plus 1, What will be the next step? If aj
AJ equal
greater than
temp,
aj plus 1, then temp equals to aj plus
then
1,
AJ equal AJ plus.
right? After that, aj equals to aj plus 1, and then
Ma'am, temp equal
aj plus 1
AJ.
a
equals temp.
plus 1 equals to temp, right? The code blocks just stopped working. Okay, we can do one thing. We can implement the program into code in our next class. Okay,
Okay, ma'am.
but you know the code, right? So you can just write the code. You can use both the condition, that is j equals to n minus 1 and j equals to n, and you will get the same result, but maybe the execution time will be different. Okay. So I hope bubble sort algorithm is clear to you, but if still if you find any problem, you can tell me in the next class.